Hi, and welcome to our presentation. Shan and I are going to talk about our study where we analyzed impacts of localizing food system on farmers' livelihood resilience. The aim of our study is to explore long-term policy options in scope of local food systems in South Australia to investigate impacts of possible policy interventions on farmers' livelihood resilience when they are facing climate disturbances. We have followed a system dynamics methodology to develop a computational model and a simulation tool, which we believe that it can help local decision makers to test likely impacts of possible policies, weigh up the trade-offs of alternative policies, and act proactively. Climate disturbance in South Australia are very tangible in recent years. Drought and heavy rains are the most challenging weather conditions for farmers. They both affect production and logistics of these products. This makes supply chain extremely fragile. We define resilience as the capability of farming system to undertake measures against recurring shocks to the system and other future uncertainties. In other words, we can say that farmers and other actors in the system need to be able to respond to these disturbances with appropriate ways. Farmers' resilience is influenced by farmer entrepreneurship, membership in farmer organization, and farmer-buyer relationship. We have included 4 policy options in our model: farmers market organization and farmer market policies are currently implemented policies. That's why we have represented these policies in our model. But in addition to these models, we are proposing 2 different policies, which are food box delivery and food hub interventions. Then we need to describe them. To do that, food box delivery enables farmers to sell their products at a better price than a wholesaler bulk price. We propose additional funding for this intervention to set up the food box delivery application and platform for farmers. Food hub enables more farmers to sell their products with farmer organization negotiated prices. It aims to sustain farmers' livelihood resilience and meet consumer needs. Funding is also proposed for this policy to set up food hub infrastructure and its operational costs. You see in the model that we created a model for this. To explore these policy options, we developed a computational model using system dynamics methodology. It's a mathematical modeling technique to frame, understand, and tackle the complex issues and problems. Our model is a continuous time model, includes dynamic stocks, as you can see, and flows. It consists of various internal feedback loops and time delays. We utilize this approach to understand the nonlinear behavior of complex local food system in South Australia over time. We also put special emphasis on implementation challenges in our model. We may say that this includes delays, capacity limitations for different structures to avoid developing a wishful thinking model. For instance, farmer market cannot grow with funding infinitely. It's very limited by other factors like size of the market and number of customers. So We ensured our model's sustainability through several tests, referring to the guidelines by Ramanathan and your Sturmenson's article dated 2012. You can see our example of um, one of the tests we conducted for sensitivity analysis on the right side of the screen. Our model structure, we based our model structure on theoretical framework of economics, agriculture, and food systems. This framework, we quantify this framework using Stella, which is a computational modeling software, and calibrated it to the collected data. We collected data from government institutions, journal articles, and interviews with the experts. The collaboration between the model parameters and existing knowledge of the system can be considered sufficient to provide confidence in conceptual parameter validity. Now, Shan will continue with the results of our study.
Thank you, Furkan. Hi, everyone. This is Shan, and I now proceed to talk about the dashboard of this model. So what you're looking at here is the main dashboard of the interface. You could look at the policy options with different buttons on the left side, and you have also the model assumptions on different fundings and also the climate shocks on the right side. And of course, the middle is the time graph where you see the first graph it's between 2000 to 2040 with the y-axis on Australian dollar per year per person. So this is the farmer income that we're looking at. So you see already a blue line over here. This is the business as usual with more of a hypothetical climate shocks that we put in to test different policy. So if you go to the different the second tab, we now narrow down to 2020 to 2040 so that you could have a better look on the difference of the projection that we make testing different policy. So of course the first thing as you switch on the funding, you see now we have a different simulation. Of course it's still the same, we haven't switched on any other thing. Let's say you want to strengthen capacity of farmer market, you click on it. Oh wow, there is a difference, but it's not much. So why? Let me try food box, right? So food box itself, it doesn't really give much difference as well. Why? Because the food box relies on the food hub, which is close to the cities. So you can't really deliver food boxes directly from each different farms to cities. It's very far. It could be very far, so that's not sustainable. So food box should start right after food hub. Let's see food hub. There you go. You've got a bigger income gain from this policy for the farmers. Then you also include the food box, then you see a different impact over here. So I will now go to explain the main difference of results. Well, you can see here again the timeline is 2020 to 2040, where you see the blue line is the business as usual with climate shocks without any policy. The red line is with two policy. You use the funding on just two policies. On farmer market capacity building, capacity increase, and the farmer market organization marketing. And the green one, as on top of these two policies, you add in another food hub and food box delivery. And you can see, of course, a combination of policy give you a best outcome of all. And in a more resilient system, you could see the farmer income drops and rises at a smaller scale during different shocks over here. And in this graph, you can't really see very obvious that buffer falling and increasing at a smaller scale over here because the farmer incomes in our model does not include personal saving that is being used during shocks, or we also not including any compensation from the government or compensation from insurance. So if those are being included, then you will see a clear buffer over here. So just for your information that you might have. So the three key message that we would like to really point out is the first one is if we focus on one policy, it might backfire. For example, farmer market is very popular, right? So if we put a lot of money into farmer market, what if there's not enough farmer to sell? What if there is not enough demand because of COVID? Then people don't want to go out to farmer market. So we have to be careful not to just put all the money into one policy. And secondly, if we really do that, then we kind of take away the incentive to also find other solutions that might give very good impact as well. So third one is that this model shows you different policy that give you a positive impact. But then we come back to the implementation of policies, because it's not just one person work to implement the policy. It's a whole range of stakeholders. So we really want to encourage a kind of group model building where you get all the stakeholders that might be involved in this implementation of policy to really understand whether this is feasible, what are the required resources, who should be doing it. So in a way, you understand the implementation challenges better, and you could also take the data and update the model later on. So that those are the three key messages we want to point out. So again, this come back to the resilience kind of causal loop diagram, and this is the very simplified version of our model structure as well as what we have in the model. And you can see how different skills could improve the adaptive capacity, and most importantly, you have more savings with different skills because your livelihood being diversified. So the money being used during shocks could also help you to adapt during that difficult times. The limitation here, we would like to say that this is our student project, so 1 month student project with a time limitation. We are not able to really quantify the soft variables, and of course we have yet to include the consumer demand policy structure in a very detailed way. So one of the reasons is that our stakeholders input has already said that because of COVID-19, there's already an increased demand for local food in Australia. So I think we focus our resources, our time, the structures and the model. So I think the next step could be focus on the consumer part, where we would like to diversify the types of consumers, because farmer market might just attract certain types of consumers, and we know that low and middle income consumers might not go to farmer market, and from there we would like to focus more on the food box delivery to target this group of people. So that's our potential next steps. And lastly, we would like to thank everyone who have been involved in the whole project, and we would like to thank our Professor Birgit and teaching assistants Brooke and Arila. They have been very helpful throughout the process. If you want to read more about this project, you could go to the appendices and go into the link and download the documents. Thank you very much. So if you have any questions to comment, we would really appreciate it. Thank you.